Hi there, welcome to the channel. I'm Mrs. R. Let's do some math. Today we're talking about absolute value inequalities. And honestly, this is about as difficult as inequalities get in Algebra 1. So stick with me. We're going to bring in our strategies from absolute value equations and bring in our strategies for inequalities, combine them, and we're going to rock this. So the first thing to look at when you're thinking about an absolute value inequality is just to remember what an absolute value actually means. So when we're thinking about this absolute value of n over 4 being less than or equal to 3, that means, kind of as a side note here, a side number line, if we have 0, it means the distance from 0 to whatever this n over 4 is less than or equal to 3. So this distance to either positive n over 4 or negative n over 4, because both would have the same absolute value, that distance is 3. This distance is 3. But remember, with our absolute value solving with our equations, that meant we had to solve it twice. We had two different things to do. We had to handle this left-hand side idea, that the negative n over 4 was equal to 3. Now this time we're not equal to, but we need that distance to still be less than or equal to 3. Then on the other side, now remember, with absolute value solving, we had two separate equations we had to solve for each one because we had the negative version and we had the positive version. So as we travel 3 units in the positive direction to get to whatever this n over 4 is, that means that that number, n over 4, is representing 3. On the other side, we've gone 3 in the negative direction, so that number is representing negative 3. Now that we realize that this absolute value part is kind of working the same way, where we're going to have to consider the negative 3 and the positive 3, we can actually write this as just a compound inequality and drop the absolute value signs. So we know we've got the less than or equal to 3. We're going to use that n minus 4. That's going to be our middle section. And then we're going to put the negative version on the other side. So both versions, since 3 and negative 3 both have the absolute value of 3, we're going to consider both options, negative 3 and 3, compared to this n over 4. And now we're going to solve just like we solved compound inequalities before. We're going to still try to isolate that variable. In this case, it says n divided by 4, so we're going to multiply by 4. And remember, we do that on all 3 parts. So obviously we're multiplying in the middle because that's what gets it to cancel out, but we'll also multiply on the left to get negative 12 and on the right to get positive 12. So ultimately, if the absolute value of n over 4 has to be less than or equal to 3, then that n value has to be somewhere between negative 12 and 12. And now that we see that compound inequality, remember, those are the ones that get graphed with the 2 dots, and we fill in the middle because, n is in the middle. So that's basically the overlap. That represents all the numbers that are greater than negative 12 and less than positive 12. So let's do another example. Here's another one. We have the absolute value of x plus 7 is greater than 16. Now, before we go to our compound inequality, we need to isolate that absolute value expression. So there's our absolute value, but we still have this plus 7 over here. We need to get rid of that. So let's rewrite. And to get rid of a plus 7, we'll use the inverse operation of subtracting, leaving us with just that absolute value of x isolated, and then that is greater than 9. Now, this one's a little bit different than the last one we did because we need x to be, the absolute value of x to be greater than 9. So part of this is definitely going to be, hey, what if x is greater than 9? That's part of our answer for sure. There's our 9 and spread up that way. But remember, the other part of this we have to compare to the negative 9. But obviously, we can't be greater than 9 and less than negative 9. So this is going to be an OR. So we're still comparing to the positive, we're still comparing to the negative, but just the way we state our answer and the way we graph it is a little bit different. And I need an open circle there. All right, there's our 9 and less than. And then just to double check, because these do get kind of crazy, the absolute value ones are tough. So let's just double check if we have 0. Let's check 0. So if we do the absolute value of 0 plus 7, is that greater than 16? If it is, then we're supposed to be shading in the middle. If it's not, then we're good. Absolute value of 0 is just 0. So 0 plus 7 is 7. That is not greater than 16. That's less than 16. So we were right to not shade in the middle. Now you could check on the left side, you could check on the right side, check some numbers that are outside. But just confirming that one of the areas either is or is not can be enough to just give you some confidence at least. So there we go. There's our answer, and then we are shaded in red. All right, we have one more example to look at. The absolute value of the quantity b minus 8 plus 10 is less than or equal to 2. So just like on the last one, our first step should be to isolate the absolute value, and then we'll figure out what we're doing with the rest of it. So we'll subtract 10. 10s will cancel. And now we have the absolute value of the quantity b minus 8 is less than or equal to negative 8. But you should pause here for a minute, because remember, the absolute value means the distance from 0, and distance is always positive. There are no positive numbers that are less than or equal to negative 8. Those are all going to be negative numbers. So this one is actually impossible. This one we would just say no solution. There are no b values, no numbers we could put in for b that would make that a true statement. So, no solution. Third example was the easiest one. So that's it. That's all I have for you for absolute value inequalities. We saw an example where we had an OR, where it got split because we needed numbers that were bigger than the positive limit. And we had an example that was an AND, where it overlapped in the middle because our numbers were less than the positive limit. So that's absolute value inequalities for you. Thanks so much for watching the video. If you found it helpful, please hit that like button. That'll help get our videos spread out to more people. If you still have any questions, or if you have another concept that you'd like to see a video of, please just leave a comment and we'll get that taken care of just as quickly as we can. Thank you again for joining me. I'm Mrs. R, and this has been Me Doing Math. Have a great day, and I'll see y'all next time.